Hello everyone, welcome back again. In today's tutorial, we are going to build a real-time spot voting application using Next.js App Router with Node.js and server-side event. So when you visit the application over here, all the players will be fetched from Postgresql database and displayed within our browser. So you can see all the players are listed over here, and you can be able to vote for your player. The players have their names, the total votes they have received, the percentage, and a button for you to vote. So for instance, when I click on votes and Cristiano Ronaldo over here, you can see the votes have been increased to 221, and you can see that a blue background to indicate that a new vote just came in. So let me briefly show you the full demo of this application. Over here, you can see our application is open in 4 different browsers. So let's assume these are 4 different users that have opened our application. So when you click on vote for, maybe you click on vote for Kylian Mbappe over here, you can see that it is broadcasted to all the connected users, and the number of votes for Kylian Mbappe has increased from 141 to 142 in all the windows. So this is powered by a server-side event, and everything is happening in real time, irrespective of where you are connected. So if I decide to vote for Cristiano Ronaldo over here, you can see that the percentage has increased and the total number of votes has increased in different windows. And this will also shuffle the position of the player depending on the number of votes he has received. If, for instance, I scroll down to the bottom of this page and I continue to vote for Ronaldinho Gaucho, the Ronaldinho Gaucho will switch position depending on the number of votes he has received. So let me continue voting, maybe in different windows. Let's assume different people are voting. New votes are coming in for Cristiano Ronaldo, and you can see that animation where Ronaldinho has switched position with Neymar da Silva. So if I continue voting for Ronaldinho, he will continue switching position, and everything is happening in real time with the help of server-side event. So at the end of the day, we are going to host the client-side application on Vercel, and we are going to host the server-side on Google Cloud platform that support streaming. This application could have been implemented on Vercel, but unfortunately Vercel does not support real-time streaming right now unless you make use of a third-party API. So for that, we are going to build a client application and deploy on Vercel and host our server side on Google Cloud Platform, App Engine in particular. So if you want to see how this application is built so that you can be able to implement this same idea in your own application, please stay tuned till the end of this tutorial. Back here on our desktop, let's open a terminal and let me zoom it. Navigate into your directory. So I already have a directory known as YouTube. So I'm inside. I'm going to create a directory known as Sports. So and inside the sports, I'm going to create 2 directories. So let me see these sports. Now I'm going to create 2 directories, one for client and one for server. But let's first of all create the one of server. So cd mkd server, cd into server, and let's initialize our TypeScript Nodejs Express project. So inside it, let's type npm init --yes, and it has initialized our package.json file. So let's go ahead and then install some dependencies. So first of all, let's install Express, npm install Express. The next dependencies that we will install is some dev dependencies. So npm install -self-dev, and we type this, we install TypeScript as a dev dependency, and we install types /nodes and space another package types /express, and we install ts node and node more for restarting our server. So hit enter. After we have done this, let's initialize our ts config by typing this command nps tsc --init. So it will create a file known as tsconfig for us with some basic configurations. Let's go ahead and open this. Let's navigate back and open the whole directory in our VS Code. So code dot. So this project is open. The directory of sport is open in our project. If we navigate into this server directory and open tsconfig, we have our configurations over here. So let's go ahead. There are some certain configurations that we need to make. So like over here, we need to configure our root directory, and our root directory for this project, we want it to be actually be an inside source. So we want to create directory known as source, and our outdeal. So let's search for another config known as outdeal. Look at it over here, should be inside dist. So distribution directory. So these are the few configurations that we make in this tsconfig file. Another thing is we need to open our package.json and configure some certain stuff. So we want it to go inside /dist, so distribution folder, and look for this. We are going to compile this project into JavaScript. So the project, our compiled files will be inside deal. We get to that. So we also need to configure our script over here. So our first script that we configure is the start script. So when we say npm start, it should go inside we should write this command node, and it should go inside what dist folder. So dist index.js, just like that. And we also need to configure our dev. So our dev, so when we're in development, we want our server to be restarting whenever we make any change. So we call ts node, which is the ts node dash dev. And we will also type this command respawn, and we also type dash dash ts, transpire only, and then we say go inside source directory, and we have an index.ts. So let's create a directory. So inside this, we create a directory known as source, and we create a file known as index.ts file. So back in our package.json file again, so when we want to build this project to finally host it on our server, so the command of build, when we want to build, we want it to actually remove, if there is an existing and this directory, we want to remove it by calling rinraf, and then we will remove the directory known as dist from there, and then we compile. So tsc -p. Let's open our terminal again and install a package known as .env for loading our environment variable. So cd into server and install npm install on .env import .env/config at the top, like that, for loading our environment variable. So after we have done that, inside the source directory, go ahead and create a file known as .env file. So, and let's set up a Prisma for our project. In order to set up Prisma, let's go ahead and install Prisma package. So npm install Prisma -f -dev. After we have installed, let's go ahead and initialize our Prisma by calling this command npx prisma init. So you can see it over here, it has initialized our project over here, and if you should go over here, you will see this Prisma directory with a Prisma with a schema.prisma file. So and inside our env, it has added this database URL. So we'll be making use of PostgreSQL, and we will configure it to our own DB. So before you ensure your Prisma is set up properly, ensure you install either MySQL or PostgreSQL on your computer. So for this project, we'll be making use of PostgreSQL. So we'll go ahead and configure our database URL to be what we have on our computer. On my computer over here, when I install my Postgres database on my computer, I have to configure the username and the password. And the username and the password over here, I'm going to paste it over here. So my username is Postgres and my password is 123456778. Then over here, you have to specify the name of your DB. So the name of your DB over here can be anything. So it can be any name of your choice. So we can go ahead and call it sports. So you can call it anything of your choice. So for now, I'm calling it, for this project, I'm calling it sports. So after you have done that, let's go ahead and open inside our Prisma directory, open the schema.prisma file, and let's model our database. So call model and the name of your table. So in this case, we are calling it player, and inside the player, we want to have ID, and the ID is going to have type of string, and we want it to be unique, so it's going to be at ID, and we want to provide it a default. In this case, we'll be using UID. So let's call CUID as a function like that, and our players are going to have name, and it is going to be type of string as well. And we also want to have a thumbnail, which will be the images of our players. We also want to have point, so the point that's or the number of votes that our players score. So in this case, it's going to be int, so let it be optional, and our default, so we want to make it 0 by default. So any player that is entered should have point of 0. So, and we want to have created at the time the player was created, and it's going to be type of datetime. So, and we have datetime, and our default should be, the default value should be now. So it's going to be now, and we also have updated at. So in case the user is updated, and in this case, it's going to take updated at, so the time that it was updated. So this is the simple model that we are going to have for this project. So after we have done this, we need to generate Prisma client. So in order to generate Prisma and client and create a migration, we need to open our terminal again, still within the server directory. Let's go ahead and type this command npx prisma migrate dev. So let's create a migration. So it's going to ask us the name of our new migration. Let's just start its initial migration. So you can see that when we run that command, you can see over here that it has created a migrations directory for us, and with the name that we specified over here, and the SQL file that has this an SQL and structure over here. And if you open our package.json file, you can see that it has installed a package known as Prisma/client file for us here automatically when we ran that command, and it discovered that we don't have this. So that's how we can then set up Prisma for our own projects over here, as basic as that. If we want to see our Prisma and DB phase, we can run npx Prisma Studio. So npx Prisma Studio. So this will show the structure of our database. So you can see the model over here, and if you click on it, you should be able to see the ID, the name, the thumbnail point, created that and updated that. So if we enter any records over there in our DB, we should be able to see it over here. We can as well be able to enter the record here manually by clicking on this enter record over here. So, but we don't want to do that. We want to do it within our application. So you can see how good Prisma has automated adding records to our relational databases. So let's open another terminal again and cd into server, cd server, and let's go ahead and set up our basic Express app in this file. Let's close these other files. We don't need them for now. And inside the index.ts file, inside src directory, let's go ahead and configure our basic Express app by importing http from what? http, and we also import express, and then we also import the type, that is the request, response from Express. So I guess these are a few packages that we need. So for now, let's go ahead and create our app. Const app is equal to express, and then we also want to get the port. So for now, let's say const port is equal to, if our server has provided a port, or we use port 8080. And we also create an HTTP server. So let's call const server is equal to http.create server function, and then we pass in the Express app that we created here. Another step over here is to go ahead and then start the server to listen on our port. So let's call server.listen, then we pass the port, and we have a callback function. And then inside the callback function over here, we say console.log listening on port, and we can specify it here, listening on port that. So our server is listening, so let's just say server listening on port. So let's go ahead and start our server. So open your terminal again, and remember in our package.json over here, we configure this dev to start our server. So let's go ahead and do that. So inside it, let's go ahead and run npm run dev. Alright, so when we run this command, you can see that npx tsdev command not found. So let's go ahead and install this package as a dev dependency. So npm install ts node-dev-self-dev is going to be a dev dependency. So let's go ahead and try it again. npm run dev. So you can see our server has started and is listening on port 8080. So, but there are some certain configurations that we need to do again. Let's go ahead and install the packages. So let's open new command and cd into server and run this npm install. We need to install CORS. So CORS for cross origin resource sharing, npm install CORS. So let's go ahead, hit enter. We also need to set up our server sent event. So we use this package over here. Go to your browser and search for this package, npm tss express SSE. So if you don't find the package, just go to npm, just go over here and search for ts express -SSE. So look at the package over here. So this is the package. So let's go ahead and copy this command and install it. Meanwhile, let's go ahead and import our CORS. So import CORS from CORS. So CORS is going to be a middleware. So CORS is going to allow our server to communicate with our client application. So let's write a comment here, configure CORS. So inside, below it, we have app.use. So it's going to be a middleware. So we call CORS, and CORS is going to take in some configuration. So let's open our object. It's going to take origin, and the origin can be an array. So for now, let's open an array and send it should listen to all requests coming from localhost 3000. That is where our client application will be running. So, and we also want it to send along with the cookies, credentials, true. So CORS over here is saying that we need to install types. So let's go ahead and do this. So you can see the error is gone. Let's also create a default route. So we can say app.get And over here, if someone visits the route over here, want to send a response, so request response, and over here we say response dot maybe send. We can call send, and we say server is up and running. So like this. So if we go ahead, if you open our terminal and we check the tab, our server is still listening. So if we go to the browser right now and we type localhost 8080, we should be able to see server is up and running. So that shows that our server is up and running. So we need to configure an express to allow JSON payloads. So in order to do that, let's go ahead and configure our express. So over here, we can say app.use, and inside it we can say express.json. So it's going to be like that. And the next one we can say app.use, and we can say express.url encoded, and we can password extended to false. So these are the basic configurations that we need to do for our server. So let's go ahead. The next step now is to actually configure our server sent event. So inside the source directory, let's create another directory known as SSE emitter. So inside the SSE emitter directory, let's create a file known as index.ts file. And inside the index.ts file, we go ahead and set up our server sent event. First of all, let's import an SSE from TS Express SSE, the package that we just installed. And we say const SSE, we create a singleton on object that we use throughout our application. SSE emitter is equal to new SSE that we just imported, and it's going to ask us for default values. What are the default event I want to send? So let's just call it SSE like that. You can go ahead and pass different values over there inside the array. So and then we export default. So export default what? SSE emitter. So, and back here in our index.ts file inside the source directory, we want to go ahead and import that SSE emitter. So type SSE emitter and it will be imported. So we want to go ahead and configure our streaming route. So below this page here, we say app.use, and we say if anyone visits /API/stream, it should be able to stream our event. So in order to initialize our SSE emitter, we call SSE emitter.init. So this is a middleware that is going to initialize our SSE emitter that will be listening to on this /API/stream throughout our application. So anyone who visits this and event is emitted will be able to listen to our SSE emitter event. After our modeling is done, we need to create a seed file inside this our Prisma. So let's go ahead and create a file known as seed.ts file. So this seed.ts file is a file that will create our initial data in the database. So let's first of all import Prisma client from Prisma. So in order to do that, Prisma client from Prisma, and we say const Prisma is equal to what? New Prisma client. So like that. Then we create a function, async function main. So this function is going to insert or create dummy data. So in order to create the player's data, let's call this player data, and it's going to be an array. And then inside that array, we want to have an object, and we want to have the name of players. So the name over here is going to be, the first name is going to be Neymar Junior. So Neymar.Junior on the silver. And we also want to specify the thumbnail for this player. So thumbnail, and the thumbnail is going to be, I'm going to provide these images later, so it's going to be Neymar. So .jpg, so that will be the image. So let me go ahead and create for other players. All right, so you can see our players data is created over here. So let's go ahead and create a function. Let's go ahead and complete this function to insert our data in the database. So first of all, let's console.log and start seeding. So we show start seeding. So, and then before we actually insert the data again, let's check. So we say const count is equal to await prisma dot what dot player. So that is the model or the table name dot count. So we want to count whether there are players inside the database or not before we insert. So if count is equal to 0, then we go ahead and insert the data. So we go ahead and say await prisma dot player dot what create many. So we say create many, and then inside the create many we have to pass the data, and we say what player data. So like that. So and then we console.log seeding complete. So we say seeding complete. So then we will, if else here we go ahead and if players have not been inserted, we insert. Else we say players data has been inserted already. So we say console.log player cd complete players already exists. So players created successfully. So after this, a function called main. We need to call this function actually for this script to work. Catch if there is any error. So if there is any error, we can and then inside it, we can go ahead and console log the error. We can send cd what error, and we log the error. So let's pass the error object here with any type. And if there is any error, we can say error dot what message. So error dot message like that. And then we can finally disconnect our database. So finally, let's call finally, and we say what is going to be, let's make it an async function, and we say await what Prisma. After the seeding, we want to actually disconnect the database. So Prisma what dot disconnect. So this is a seed file or seed script that is going to actually insert these players data on database startup. So it will first of all check if there are players in the database, then it will skip, else it will actually insert player data in the database for us. So after we have written this function, we actually need to open our package.json and configure a Prisma command to actually see this data into our database. So open your package.json, and below the script over here, go ahead and type this command, and then the command is Prisma. Then you open your column, and then you pass in seed ts node prisma slash c.tss. So this prisma slash c.tss, the c.tss file that we have specified over here. So after we have done this, we save our command, and in order to see this data into our database, so in order for these things to work, we need to type the command npx prisma db seed. So we wait for it. You can see it is running our command, running seed command, and it says start seeding, the same thing that we specified over here. And if you open this, we say start seeding, and you can see it says what seeding complete, players created successfully. So we already started our Prisma Studio over here, and it is running on port 5555. So when we go ahead and open our browser over here, and we refresh our browser tab, this Prisma Studio, it will show us the data that has been created in our database. So you can see it over here, all the players data that we just created in that file. So whenever we run this command npx prisma db seed, it will seed our database on startup. So this is the basic configuration that we are going to do. Let's close these other files. So in order to do that, let's create some directories. So let's create the controllers directory. We create and services directory, and we create another directory known as what route. Let's also create a directory for configuring our database. So we create a single instance and use it across our application. So let's call it db. So inside the db over here, let's create a file known as index.ts file. So and we import Prisma what client. Let's create an object, so a variable Prisma be equal to what is going to be a type of Prisma. So let it be Prisma. We are going to assign it, and below it we check if process.node is equal to production. Then we will just say what our Prisma file that we have created at top there is equal to new. We create an instance of that of Prisma client. Else, if it is in development, to avoid, remember that our server is going to be starting, so to avoid creating multiple instances of Prisma, we go ahead and check if it is existing globally in the global object. Else we create a new instance. So if global Prisma, so const global Prisma is equal to global as what type of global as type of global, and what then we'll assign this Prisma object Prisma. So but for now, let this object be optional. So over here we now say our Prisma is equal to global Prisma. So on this one that we just did over here, so let's change this to a camel case. So we say global Prisma dot Prisma. So dot Prisma if it exists, dot Prisma, or we say or what new Prisma client. So like that. If not global Prisma dot Prisma, then we will go ahead and assign this Prisma to a global Prisma. So on the Prisma object, so this one over here. At the end of the day, we now export what default what Prisma object. So on this Prisma instance will be used across our application. The next step over here is to create a service file. So in order to do that, let's create another directory inside. Supposing our project has different features, so let's create a players directory, and inside it we create index.ts file. So inside the index.ts file, we go ahead and create functions for communicating with our database. So first of all, let's create a function export const to get players, to get all players from our database. Const and get players is going to be an async function, and then it's going to have a try and catch block, and inside it over here we say const result. We want to fetch all players from the database. So const result is equals to await Prisma, that Prisma that we just configured in our DB file, Prisma dot what player. In order to get data from a Prisma model or table, we call Prisma the Prisma client object dot the name of the table or the model dot what find many. So like this one, want to get all the players over here. So and then we pass in what an empty object like that. So from there we return the result. So it's going to be an array of players. If you hover over it, Prisma has types, and it will show us that it's going to return an what ID, name, thumbnail, point that you say in the player object. So it's going to be an array of players. So but what if an error occurs? We throw an error. So we throw the error. We create another function of what of actually voting a player. So export const vote player, and we say it's an async function that is going to take what player ID, and the player ID is going to be string. And let's have a try catch block again, and we say here const result is equal to await. You want to update the player's point or vote, so await Prisma dot player dot what update. So in order to do that, we want to update, and if you open this update object, it will ask us for the data that we want to update and the condition. So the data over here, we want it to be ID. The ID is going to be mapped to the player ID over here, and no, this is the condition actually. So we want to update the player point. So over here is going to be point, and then we want to, since it's a number, we can be able to call this increment over here. So you can see Prisma has made it easier for us to actually update in an int type. So over here, and we after this, but where do we want to do that, on what? So we need to specify where, and inside the where we want to update a player where the ID is equal to the player that is provided over here. So if I vote a player, I have to send along with the player ID, and we update the player point, that is increment it by 1. So below this, after we have inserted data, we want to go ahead and emit our SSE event, broadcast it to all users that are then emit SSE event. So broadcast this event to all users that are connected to application so that they will receive this data in real time. So we go ahead and call SSE emitter. So remember, we created SSE emitter object inside SSE over here. So we're going to use this and broadcast this to our application using SSE server send event. So we call SSE dot, it has a method known as send, and the send method takes the data. What data are we sending to the client? So first of all, we are sending this updated player point. So on this object, updated player object, and we also need to specify the event that we'll be sending. So let's call this name, the name of the event can be anything, but let's call it player voted. So that will be the name of the event. So and then we go ahead and return the result. If anything, if an error occurs, we go ahead and throw the error. So just like that. So on this error over here, we go ahead and throw it. After we have created our services for communicating with our database, we go ahead and create a controller for handling all requests that are made to our route. So inside the controllers directory, let's go ahead and create players directory, and inside the players directory, let's go ahead and create index.tss file. So inside this, we go ahead and call export async function. Export async function what get players controller. So get players controller. So it's going to be a function over here, and this function will take the request. Since it's going to be a middleware, it's going to take type of request, express request, and it is also going to take a response over here. So remember, it's a middleware, so it's going to take type of response over here. So try catch block. So inside it over here, we're going to say const players is equal to await get players, the function that we created in our services. So get players, and all we just need to do is to return response.json, and we pass in the word the players. So and if any error occurs, we return what response.status, and maybe let's just pass 500 that an error occurred on the server. So dot what we send the error, so we can just say sorry, an error occurred getting players. So like that. So we also create another function for voting. So export async function vote player. So vote player controller. So it's going to be async. It's going to take a request response, and inside it is again, it's going to be a try catch, and we say we want to get the body of the request. So we say const body is equal to const body is equals to request dot body. So, and we want to do a brief check. Maybe over here you can add a validation. So if not body, or if not body dot the player ID, we want to go ahead and return an error. So let's go ahead over here and return what response dot status, and this time around we say status 400. So over here we change it to 400, and we say invalid request payload, invalid requests payload. And but if there is no error, we go ahead and vote the player. So const result is equal to await and vote player. We call the function from services vote player, and we need to pass in the player ID. So we say body dot what the player ID. So like that. If everything happens, we go ahead and what return res.json the result. So as if an error occurs over here, we copy this same error and we change the error. Sorry, an error occurred. Voting player. So like that. So after we have done this inside our control, we need to open our route and also create the players route. So players, and inside the players we create a file known as index.ts file. Let's import an express from express, and then we get the router object. So const router is equal to express or router, and we say router dot get. So if a user makes request to /API/players, we will actually call the what the get players controller like this. So it's a middleware, so we can actually call it like that. All right, let's just go ahead. We fix this issue. So router again, router dot post vote. So if a request is made to /API/players/votes, then we can go ahead and call the vote player controller. So if you are facing this issue, is because our types have installed Express version 5. So go ahead and open package.json over here. You can see our types. Our Express types is version 5.0, but our Express is 4.2.1. So we go ahead and downgrade this Express type. So go to the browser and go to npm. We can come over here and search for types, Express types. So let's go ahead and open it. So you can see it over here. This current version is 5.0.1. So let's go to versions and see the one that is compatible with 4.21. So you can see another stable version over here is 4.17.21. So we don't want to use 5 yet because we're not using Express 5. So let's go ahead. The version over 4.17.21. So let's go ahead 4.17.21. So let's go ahead and install it. So let's check if our error is gone. So you can see the error is gone over here in this file. So we can go ahead and save the file. So after we have configured our route, we need to actually come to index.ts file over here to call our route. So in order to do that, we can come over here and say app.use, and if anyone makes a request to /API then we actually call this and this function. This is our route function. So let's go ahead and call route. Okay, we have not yet exported this, so let's go ahead and we can actually change the name. So let's go ahead and export default route or router. So like that, and when we come to our file over here, we can call router and it will be imported from players, but let's call it player router. So, and we call this one, copy it and pass it here. So if someone makes a request to /API/players, then this will answer it. So if we open it, so that at the end of the day, we are going to have a request /API/players like this. And if it's to vote /API/players/vote. So, and this particular router or route file will answer we handle the request. So let's check if our server is still running. So our server is currently down. So let's go ahead and npm run dev to see if there's no any issue. So you can see our server is still running. So let's go ahead and check it out in the browser and see if we can get players data. So over here in the browser, if you open localhost port 8080 and hit enter, our server is still up and running. So let's try to visit the /API/players and see. So if you visit it, we should be able to see our players data over here. So that you say we can now be able to consume it in our client application. So likewise, if you open /API/stream, we should be able to see our stream data, the one that we specified. and then our stream will be listening. So any event that is emitted over here will show up here in the browser. So since our server is up and running and can handle requests, we now have to actually create our client application and consume this our API in our client application. So for this client application, we're going to be using Next.js on the client. Okay, so let's go ahead and bootstrap our Next.js application. So go to the browser and search for Next.js, and we will have these commands over here. Let's copy the commands. Now we get back to our terminal, and we will want to create, but we don't want to use the latest version, so we want to use 14.2.16, and we want to call the name of the app client. So let's go ahead and start it. We answer some few questions. Do we want to use TypeScript? Yes. ESLint? Yes. Tailwind? No. Source directory? Yes. App router? Yes. Import alias? Yes. And we specify it like this and wait for it to install. Alright, after it has installed or created our project, if we navigate back to our VS Code, we should be able to see the client directory. So inside the client directory, we have to go ahead and configure our app. So first of all, inside the client directory, let's go ahead and open a terminal and navigate to that client directory. So let's cd into client directory, and we can run npm run dev to start our client application. So if we open this in the browser, we should be able to see our client application up and running. So you can see our client application over here. So let's go ahead and configure MUI. So open new tab and search for MUI and go to installation. So under the installation over here, let's copy this and install. Copy this, navigate back, and let's open new terminal and cd client. And inside the client, we want to install MUI. So install that, and we also need to install Roboto font. So copy that command as well and navigate back, paste it over here, and we need to copy this over here. So let's copy this, import, and take it to open the source directory app and open layout file and paste it over here. Let's go ahead and remove everything that is here. So, and we don't need these classes over here as well. So the next step for us now is to install the icons as well. So let's install the icons. Then we need to also import this style for icons, for material icons. So open our globals.css and remove some styles over here. So we don't want this, and down here we don't want them. So at the top over here, type @import, then paste the CSS URL for material icons. The next step for us is to actually configure Next.js for MUI. So MUI, search in the browser MUI Next.js. So, and it will take us to Next.js integration over here, ask us to install some packages. So just copy this and take it back, install within the client's application. And we need to also import this at the top over there. So inside the layout over here, let's import it there. Then we need to wrap the whole of our application. So inside the children, we need to wrap this, and here, let's paste it as well and close it up like that. So I guess the packages have been installed. Let's also install Azure. So we are going to be making use of Azure to communicate with our server. So in npm, still within the client directory, npm install Azure. So as Azure is installing, let's go ahead and configure it. So within the source directory inside the client, go ahead and create a directory known as config, and then create another directory known as component. So component. Let's create another directory known as interfaces. Let's create another directory known as lib, so as in library, so lib, like that. And inside the config, let's create a file known as index.ts. So we need to configure our Azure for communicating with our API. So before that, inside the client directory, let's go ahead and create a file. We create two files known as .env.production. So, and we create another file known as .env.development. So in the production, we specify our production environment variables, and in development, we specify our development environment variables. So inside the development environment variable, let's create a file known as, let's create an environment variable known as next_public, since we want to be using it in the browser. API_URL is equal to, so we want to, here we specify our server URL. So HTTP, our server on the local host, it is hosted at localhost colon 8080. So, and /API. So let's have that like that. So, and the next step, the next one in the production, we copy the same, but if it is production, it's going to be different. So over here is going to be an HTTPS. We configure this one later when we're about to host the application on a remote server. And inside the source, inside the config, let's go ahead and configure our Axios. So first of all, we need to import Axios from Axios. So import Axios from what? Axios, and we create an instance of Axios. So exports cons, we call the Axios API, and is equal to what? Axios.create. We create an instance of Axios. So and inside it, we need to pass the base URL for our server. So and we already created that environment variable. So let's go ahead and call it this name over here and pass it like that. And we also need to specify with credentials, so if you want it to send along with cookies, so true. So that is just the basic configuration that we're going to do for our Axios. We also need to, inside this interface, let's create another file known as index.ts file, and inside it we want to create one interface, export interface what app player. So it's going to take the shape of what of our app player on the server. So inside it over here is going to have id of what string, is going to have name of string, is going to have thumbnail of string as well, is going to have created art, so the time, so created art of string, is going to have updated art of string, and it is going to have what point of what string. So this is the type of our player, app player. Inside our lib, let's go ahead and create another directory known as players. So, and inside the players directory, let's create a file known as index.ts file, and then within this we will actually create a function for getting our players. So for voting our players, so export const vote player, so vote player, and it's going to be an async function that will take the player id as a string. And over here is going to be inside the try catch block, and within this we're going to say const result is equal to await. We use our Axios to communicate with our server Axios API, the one we just configured. Axios.what post, we are actually going to post to /. But before that, in our Axios config, let's configure this. Our base URL, we actually want our base URL to have /what API configured here like this. So the base, so at the end of the day, is going to be our base URL / what API. So over here, when we are calling, we call the base URL will be appended here automatically, and it will be / what players / what votes. So and then we pass the data that we want to vote. So this is gonna take the player, take the player ID over here, and then we pass an object that will contain the player ID over here. So this will be the payload to our server. So from here we want to return what the data that will be returned from our server. So it will be response.data as what app player. So app player is the type of our app player over here imported from interfaces. So and the message is simply going to be what player voted. So let's just have what player voted. So and if an error occurs, we first of all say let message be equal to error.message, and our error here should be any. So let's have that. And if our error contains a response, if error.response, then we will have to reassign this message to what error.response.what.data. So whichever error response I sent from our server, we get it here. So at the end of the day, we want to return what here. This data will be what now, and our message will be message. So that is just it. Just this simple function for voting our player. Let's create another directory inside the source under client known as context. So we call it what context, and inside the context directory, let's go ahead and call it SSE what context. So let's call the name of the file SSE context.ts6. So first of all, this is going to be a client component. So we say client, use client at the top over there, and we want to create an interface of what of SSE context type. So let's call it an SSE context and then type, and it's going to have a type of what SSE source. And over here we're going to have what event source. So it's going to be type of event source, so or no. Now let's create a context using React context. So const SSE context is equal to create context from React. Create context is going to come from React, so let's import it from React, and it's going to take type of what of SSE context. So let's pass it like that. But for now, we want our SSE source to be what to be no. Remember, we specify the type over here to be what event source or what no. So over here, let's create a context provider. So const what SSE context provider is equal to, is going to be a function that will take props of any. So and over here inside it, let's create a state. So we call use state. So we call this one event. Let's call it event source like this, and it's gonna be type of what, event source or not. So let's copy this same thing and pass it over here, or let's just say it's gonna be event source or what, or no. So and close it, but for now the default value should be what, no. So we import use state from React over there. Next step for us is to create use effect to establish our connection. So, and we also import use effect from React. So if our application has launched, so we can call SSE source is equal to, we try to make connection to our server, and by calling event source object is already built in our browser. And then over here we need to specify the URL where we want to make our request. So remember I said our URL is going to be process.env dot what dot the env, the environment variable we created over here. So this is our server. So then we'll be making requests to our API. So process.env dot the name of our API, the URL to our API slash what stream. So this is the route that we're going to be listening to real-time event on our server. We already created it on our server when we configured our server. So at the next step over here, you need to pass an option. So we pass with credentials true, so that it will work well with our server. So at the next step over here, after this has established the connection, we want to go ahead and set this up to this so that we can now use it in our application. So we can go ahead and listen to some event. After this, we can listen to some event over here, like we can call SSE source, this object that is here, and we can attach event, add event listener. Maybe we want to listen to global message event over here, and it will take a callback and the type of the event. But if you hover over it, it will tell us that it's what type of message event. So it can be what message event. So it's already built in our browser like this. So, and within this, we can just go ahead and console.log. Maybe we just want to show that our client has received an event. Our client is connected to server. So, and we can go ahead and log the event to server stream, and we can go ahead and log the event, maybe event.data. So event.data like that. If we receive it on this message event, we can also check if actually an error occurred when trying to communicate with our server. So we can just say add event of error, or we can just say SSE source dot on error. So like this, it is still the same and it will work. So on error, it should take what ev, that is the event, and actually log the error. So console.log and SSE error, SSE error, and we log the error like that. So let's go ahead and remove that. So at the end of the day, if this component is on mounting, we want to go ahead and destroy the or close the SSE connection. So SSE dot what close if this component is what on mounting. So let's code it like that. After we are done with our configuration, we go ahead and return our context provider. So SSE context dot what provider, and the value over here is gonna be the SSE source. So remember we configured our context over here to have our SSE source. So we now go ahead and pass it the value of this event source, this state that we created over here, because when this component initializes, we go ahead and set the state to the SSE source. So that we can use it globally within our application, and this will wrap the whole of our children that are passed to this and context provider. So props.children. So after we are done with this, we can go ahead and export this as a default component. So export default SSE context provider, and we also want to make use of this context as well. So we can go ahead and call const use SSE context. So use SSE context, and is equal to, it's going to be a function that we take and use context from React, and we're passing this SSE context. So let's export it as one so that we can be able to use it inside any context within our application. So if we can also specify that the type should be what type of SSE context when exporting this. So over here, that is what we'll be expecting. So let's go ahead and save everything. So you can see our server is still running. So let's go ahead and make use of this context. So let's close these files. Alright, let's open our layout file. Now we need to actually import that context, SSE context provider, to wrap the whole of our application. So in order to do that, we can come over here and open SSE context provider like that, and we wrap the whole of our application. So wait, the whole of our children like that. And we also want to make use of React Toastify. So let's go to the browser and search for npm react-toastify. So this is a library over here. Let's copy this command and install it. So open the browser within our client application, go ahead and paste this. So in order to make use of this, we need to actually import the Toastify container. So I guess our package has installed. So before this children, let's go ahead and import toast container, and then we pass it auto close, and the timeout should be just 200. We want to make it short, and it will be safe closing. So let's import toast container from React Toastify. So import toast container from React Toastify. So just like that. So the toast container is actually a named component, so it's going to come like that. Toast container from React Toastify, and everything looks good. Let's open our component directory and create another component known as playercard.tss. So inside the playercard.tss, let's go ahead. I will paste this code over here and explain. So first of all, we created a component, and we are going to install a library known as Nodejs. So let's go ahead, open our terminal and npm install Nodejs. So Nodejs is a library that provides us with utility functions for making our development life easier. So we also install another library known as MUI lab. Let's install this npm install MUI lab. So Nodejs is asking for types, so let's copy this. All right, so let's install the Nodejs types. So all I've done is I've created a component and I want to forward the prop. So I call react.forward ref over here, and it's gonna I will be expecting, and the props that I'll be expecting here is a player, which will be type of player, the rank number, the voted ID over here, the percent, and then toggle processing. So we actually want a situation where if we click on a button to vote a player, we want to disable all the players and button so that no player can be voted, so that different players cannot be voted at the same time. So after that has completed processing, then the user can be able to vote another player. So, and then we created a debounce over here so that when a user clicks on a button multiple times, we'll be able to send that event once. So the bounce will wait. If you click multiple times, it will only send the last clicked event. So, and this underscore Nodejs is imported from Nodejs library, and the bounce function is called. And in the bounce, we pass the time that we want it to wait until it will be able to actually execute that function. So we created this and we call the vote player, which is the function that we created over here in our lib. So this function over here, and it takes player ID. So when a user clicks on the button or voting, it will pass the ID over here to our server and vote. So we created a function. We created a use effect over here. When the component on mount, we want to cancel the debounce function. So, and then we created this function over here that will prevent our page from maybe refreshing or any event by calling event.prevent default. And we want to toggle processing true. Remember I told you that when a player is clicked to be voted, we don't want any other player at that time to be voted. So we disable other players. So while it is processing, so all we have done is we have also called this card over here. We call grid to display the rank of the player on the chip over here, and we display the player name as well, the votes that is in percent, and we have a button over here that will show a loading spinner. So loading button from MUI lab. So loading button coming from MUI lab over there, and we display the name vote over there, and over here we display the player thumbnail. As simple as this. We need to also create another component known as home client.tsx. Inside this home client, we need to I will paste this code over here and explain in order to save our time. So we need to actually install another package known as React Flip Move. So npm install React Flip Move. For that will give us that kind of animation. So if our component has been shuffled as we voting players and the total number of vote changes, then this is going to shuffle our cards and give it that kind of animated effect. So we have created a function to calculate the total votes of players. So we look through it, we get the total points of all the players by using reduce function, and we also get the percentage. So, and we have our home client component that's going to take players from our server. So we're going to fetch the players data from the server and pass it to our client component. And we have created we have imported our use SSE context so that we can be able to go ahead and listen to event as new votes are coming in. So we created this use effect. We created a function, a callback function, that when we listen on this player voted event, SSE event from our server, this function will be triggered. So over here, we first of all get the data, the stream data that is coming from our server, and then we call the set state over here, look through the player, where the player ID matches that, we will now pass the event. We will now pass the item, that is the data that is returned from our server. So we check here if item ID is equal to the arg. So arg is the data that the stream data is returned from our server. Then we replace that as we pass back the item data that is over here. So, and we want to set a set timeout for our animation to show. So if a player is voted, we want to animate the ID or to show maybe a blue color to show that this is the current player that has been voted. So we are going to see this, and when these components on mounts, we now call this add event listener player voted. Remember on our side we are emitting this event, SSE event, so we're going to listen on it and call update vote. So update vote is a callback function over here, and it will go ahead and set our state and everything. So when this component is on mounting, we want to destroy this event. So to clean up the state, so we go ahead and create a function toggle processing. When it is processing, we want to set it to var, so this can be true or false. We also want to sort the players based on their point. So if a player has 2 and another one has 1 point, then the 2 points should be ranked higher. So, and we use this use memo to calculate the total number of votes that each player has. So we go ahead and pass a bg2 over here, background. So I'm going to go ahead and add this background in our client application. So let's create a directory known as public where we drop our files. So over here, I just created an overlay over here and call a container element, create a typography element, center it, pass it from something of cursive. Then I'll look through my sorted players. You can see over here we are sorting the players based on their point. So and we go ahead and call fade, create a grid. We import a grid to layout from material UI. After that, we call this flip move. I told you flip move is a library. It's an npm library that helps us to add animation to our shuffled array data in React. So let's check it out in the browser. So over here, if you go ahead and search for npm React flip move, you should be able to see different examples. So it's going to add animation. So this is going to be appearing like this. It's going to add this kind of animation to our card element, to our player data. So that is what that flip move is going to detect when our data is being shuffled and add animation to our data. So we also call this fade from MUI, so that when a player is voted, we fade the card of that particular player that is being voted. So this is how simple this home client component is. So after this, still within this and inside the client component, let's go ahead and create a file known as index.txs, and then we will export default as what home client from what and slash what home client. So like this. So we go open our app directory inside our page. We go ahead and remove everything inside this page. We don't want this default data over here, so let's close this main. So first of all, we want to change this into an async function so that we can fetch our data from our API. So over here, let's call const URL for making, we get the URL by calling process.env. The name of our URL environment variable. So over here in the development, the name is what Next_public_API. So over here, pass it like that, and the URL is going to be to / what players. So players like that. So, and we want this to be a dynamic component so that it won't be cached. So export const what export dynamic is equal to what false dynamic. So like that for Next.js. So false dynamic, and within this our home component we call const result is equal to await fetch. We are going to use fetch on the server over here and pass the URL, and we specify the method. The method is going to be get. We want to get the player data, and we want to pass next, and then we say revalidate as 0. We don't want this component to be cached over here, and we close our fetch function. So, and we check if an error does not occur. If no result, if no result.ok. So if result is not okay, we will return and a p tag over here, simple p tag, to show that error fetching players data fade. So like that. But if error does not occur, we will go ahead and say const players is equal to, this is going to be type of app. Remember the interface we created, app player. So be an array of app player, and we're going to await results dot what JSON. So in order to get the data from our API that is fetched using fetch API, we are going to call this an await results dot what JSON. So this will be an array of players. From here, we can now go ahead and call our home client, which is expecting an array of players. So home client component, so it's expecting a prop of what players. So we go ahead and pass this players variable that we created over here and save close the component. So let's save everything, remove this. So over here, I already have my own images, my players images. So I'm going to copy this and move them to our public directory. So inside our sports directory, client, and then inside our client public directory, go ahead and paste these images. All these files, I'm going to publish this and report to our Git directory and provide a link in the description so that you can get the player images. So after we have done that, if you open our public directory, you should be able to see the player, the BG, and the player images over here. So let's check if our client server is already running. So it is still running. So let's check it out in the browser and see. All right, so when you go to the browser and you refresh, you can see the way our application is looking. So let's go ahead and first of all remove these styles inside this page file. So let's remove that and check it out. So over here again, we remove the styles on the div element. Let's refresh the page so you can see everything is looking great now. But you can see our percentage is saying not a number, not a number. In order to fix that not a number percentage, let's go ahead and check if vote is equal to 0 and total is equal to 0. Then we return this 0.00% to remove that message or not a number. So if you come to the UI over here, you can see everything is looking great. So, and if we inspect the browser over here, you can see that the connection that we established within our context over here, you can see it says client connected to server string SSE. So that is the connection that we established in our word context file. So if you open this over here, we established the connection to our server stream over here, our SSE server stream. Remember, we already have an API, so the public API URL /API/stream. We established the connection, then we listen to message event. So this is the one that's saying client connected to server stream. So, and you can see it over here, client connected to server stream what SSE. So we specify the data that is returned from our server is what SSE. That is the one that we provided on our server. So let's go ahead and try to vote and see. So if for instance I vote for Neymar over here, you can see where is this error coming from. So you can see cannot post to /API. That is the error that is returned. So let's so you can see this awful looking error over here is because we did not import that toast and toastify CSS. So let's open our toastify over here and then check how to use it over here. So we need to import this CSS file in our app layout. So go to layout over here at the top and import this CSS file over there. Let's remove this one, save everything. So let's try voting again, and when we click, you should see this error over here. So we made a mistake. We have /API/API/player/vote. That is not the correct API. So let's go to our function over here on the client side under lib. So over here we still specified we have a post/vote. So if we go back to our config over here, we already have /API over here. The environment variable already have /API, and we are still specifying API in this config over here. So let's go ahead and remove this over here, and that should fix our issue. When you come to our browser, let's refresh the page and let's click on vote. So you can see Neymar has 1 vote. So our server is actually streaming the event to our client application. So let's inspect and see. So if we go over here, SSE stream received, if we expand that, you can see the stream that is coming from our server over here. The name is Neymar and everything. So you can see the URL that is connected to our server as well. So, and if we go ahead and vote for different players, so you can see and Ronaldo is having 1 vote, and if you vote for Hazard as well, and you will notice that the currently voted player has that blue background over there. If you vote for Mohamed Salah, you can see it over there, and if their vote changes, you can see the flip move, that is the animation, the library that we used over here. So you can see that our elements will exchange and positions, and we show that animation. So, and if we vote for a player that we have 2 votes now, they will actually exchange position. If this one to get 2 votes, they will exchange position. So you can see that cool animated move. So we can go ahead and vote for other players as well, and everything looks cool. So we can open this application in multiple tabs and test it. All right, so here you can see we have opened this application in different browsers. So we are going to test and see if all the browsers will receive all the streams at the same time. So when I click on vote Cristiano Ronaldo over here, you can see all the browsers have received the stream in real time, and everything is in real time. So if I click again to vote for Ronaldo in that point, if I click to vote for Mohamed Salah over here, you can see all the browsers have indicated the player that is currently voted. So if I scroll down to the bottom and scroll down to the bottom, this one too to the bottom, and I vote for Maradona, you can see Maradona will switch position in all the browsers. So these are different users that have accessed the application, and as the votes are coming in real time, everyone will be receiving the stream in real time. So how awesome is that? So now you have built a real-time voting application. So you can vote for your own favorite player. You can use this application to present to your employer or anyone else, or you can add this cool looking functionality within your application to receive real-time stream. So since we have created this cool looking stuff, we are going to go ahead and see how we can be able to host the client application on Vercel and host the server-side application on the GCP, that's Google Cloud Platform, using App Engine. So also, if I expand this and I come to our Prisma Studio interface over here and I refresh the page, you will be able to see all the points reflected in our database. So this is persisting our point in the database, as well as streaming our data to the client application in real time. How cool is that? So let's see how we can be able to host our client application on Vercel and host our server-side application on Google Cloud Platform. In order to host our application, first of all, let's host the server side first. So in order to host the server side on Google Cloud Platform, let's first of all make some configuration. So let's create a file known as .gcloudignore. So we create a file known as .gcloud.ignore. So inside the .gcloudignore file, we paste this. We want to ignore the distribution folder and ignore .env file. So we don't want to copy this to our Google Cloud server. So the next step for us is to create a YAML file. So inside this source directory, we create a file known as app.flexible.yaml like this. So, and we paste this configuration inside. So create an app.flexible.yaml file within the server directory, and then type these configurations. So specify the runtime as Node.js, the environment as Flex, and then we specify the operating system as Ubuntu runtime, Node.js environment as 20. Then we also specify, like this one, we say it should be manual scaling, specify the instances, the resources, the memory. And the most important thing over here to enable real-time communication again is this session affinity. Just set session affinity to true. We also need to specify some environment variables that are needed when we are building this application on the Next.js and on the Google Cloud server. So over here, we need to specify our database URL. So our database URL for our Postgres URL, we are going to be making use of our Postgres URL from our Vercel server. So let's see how we do that. We get the connection string. So over here in the browser, visit vercel.com and log into your Vercel account. So when you log into your Vercel account, over here, this thing, go under storage, and like me, I've already created a database. If you have not yet created a database, so go ahead and click on database and choose PostgreSQL and click on continue. So but I've already created a database, so I'm going to go ahead, click on it to open. So when you click on it to open, come under this env.local and click on show secret. So it will show you database connection URL. So you can go ahead and copy this connection URL that is here and then take it over there. So when you come over here, when you copy the connection string, go ahead and paste it. So paste it over here in this, specify the env variables. So the database URL, this is the one that will be used by our Prisma. So if you open our Prisma schema over here, it's making use of our database URL environment variable. So there is a way Google Cloud Platform configures its own environment variable. So you need to provide everything in the YAML file. So that's the reason why we are specifying the connection over here. So you can go ahead and configure it just like this. So these are my connection. This is my connection string from my Postgres. Your Postgres database can come from anywhere, provided you can be able to connect your Google Cloud application to it. So we save this. After we have saved everything, let's open our package.json, and within our script over here, we need to configure to add some commands again. So over here, let's actually we'll remove this test. This one over here, I have pasted some setting commands. If you start from here, I have prepare, npm run, gcp build, I have pretest, I have lint, I have deploy app. This is my custom commands that I've added, and I've also added this deploy over here, referencing our app.flexible file. So you can see when I call this gcloud app deploy app.flexible YAML, I want it to go ahead and read all the information within this file and deploy my app to to App Engine Flexible. So I have my compile. I also have GCP build. So GCP build is where you provide your own custom commands over here. So in order to actually host our or let our GCP application communicate with our Prisma database, we want to actually during the build we want to generate our Prisma client application and also actually migrate our schema to the database. So based on the connection URL that is provided over here and our Prisma, these commands over here can be able to migrate our database to the specified database. After that, we want to seed our data into that particular database. So it will read this our seed file over there, that command, and seed our data. If the data already exists, it will skip, but if it doesn't exist, it will create new and inside the data inside our database. Then we run what? npm run build. So npm run build will actually run this command over here that is specified. So these are the few configurations that you need to do for our app to deploy our app on what? Google App Engine. So all these things, with a quick research on deploying Node.js app on Google Cloud App Engine, you'll be able to see all these commands. And I'm going to also push this repo to our GitHub. So the next step over here is to ensure that we have installed gcloud on our computer. So over here in the browser, just search for gcloud CLI. So go ahead and search for gcloud CLI, and it will take you to this documentation where you will learn how to actually install your gcloud Google Cloud CLI on your computer, be it Windows, Chromebook, or Linux, or Mac OS. I'm running on Mac OS, so I've already installed this gcloud on my own application. After you have installed gcloud on your own application, let's go ahead and then create a project where we deploy our App Engine Node.js application. So go ahead and search for Google Cloud Console. So Google Cloud Console will take you to this console platform. So this console platform over here, you can be able to create a project and actually deploy your application. So go ahead over here, add your billings and cards. You can set up your billing with the help of Google documentation. You can be able to set up your billing. So after you have done that, go ahead and create a project. So we create a new project and we call it an SSE and sports demo. So that would be the name of the project over here, and we click on what? Create, and wait for it to create our project. After our project is created, go ahead and select the project. So our project is selected now. So let's go to the dashboard, and we will actually go to enable API/services over here. We want to enable Google Cloud App Engine, so click on this icon over here and then search for App Engine. So App Engine, so you can see it here, App Engine as one of the services. So the one that we want to enable is this Google App Engine Flexible Environment. So go ahead and click on it and click on enable for that particular project. So you can see our project is SSE Sports Demo. So that is the name of our project. Let's wait for it to enable. Alright, so you can see our Google App Engine Flexible Environment is enabled. You can see API enabled over here. Alright, so once you visit the dashboard over here, go ahead and search for App Engine. So this App Engine, so since we have already enabled the service, click on App Engine and click on Create Application over here, and it will ask you to select the region where you want your application to base. So we will go ahead and use the default region and wait for it to configure our application. So after it has configured, the environment that we want to make use of is Node.js, and the environment is flexible, not standard flexible. And you can go ahead and click on this link to open the GitHub to see how the code examples or code samples, and also visit the documentation for flexible environment. So you can see some series of commands it has asked us over here. I asked you to install this gcloud on your computer. So, and we are going to copy this command and run within our own terminal. So let's copy the command. Alright, so within our terminal over here, let's go ahead and open this, and we want to navigate to our server directory. So within our server directory, go ahead and paste this command of Google Cloud init. So let's wait and see. Alright, so this will ask us to actually specify, do we want to reinitialize the project? So it's picking my default, my previous project, but now I want to use a new project. So I'm going to choose number 3. So just choose number 3. And once I choose that, number 3 is asking us which account do we want to use. So I'm already using CodeSamon, so I'm going to make use of that. And it's asking, it has listed all the projects under CodeSamon, but you can see the project we just created is number 2. So let's go ahead and enter number 2. SSE Sport Demo, that is the project that we just created, and it's asking, do you want to configure a default compute region? So we say no, we already done that, and you can see it has configured and everything is successful for us over here if you see this. So the next step for us now is to actually deploy this application. So if you run the command Google Cloud App Deploy over here, is going to look for an app.yaml file. But remember that we changed this name to app.flexible.yaml file, so you can actually have many YAML files over here. And we also configured in our package.json that when we run the command and npm run deploy, you should call Google Cloud App deploy, then the name of the YAML file. So the name of the YAML file here matches this YAML file that we just created over here. So we are going to go ahead and instead of calling app and Google Cloud App deploy, we are going to actually run the command npm run deploy. So this is the command that we're specifying in our package.json over here. So when we run this command over here, it's going to go ahead and deploy our app to Google Cloud Platform. So it will call gcloud app deploy app.flexible. So it will pick the configurations of our server over here in this file and deploy our app to Google Cloud Platform App Engine. Before we run the command Google Cloud App deploy, let's go ahead and configure our app, add this configuration in our ts.config file. So let's include everything inside the source and let's exclude node modules. We don't actually want to push these node modules to our server. And in ts.config file, we also change this to target ES6 like that. Let's try to actually build our project and see if everything is working right. So let's run the command npm run build. So if we check, we should see a dist directory over here and you can see everything. So since our build 2 is running, let's go ahead and then try to run this Google Cloud App deploy and see. npm run deploy. So it will ask us for confirmation. We type y, which is yes, and wait for it to actually deploy our app. Alright, so you can see our app has finished deploying to Google App Engine. So, and there is a command that is provided for us over here to see the app. So we are going to go ahead and type Google Cloud App browse to actually see the URL to our app. So it is opening the browser over here. You can see our app says server is up and running. So our Node.js app is deployed to Google App Engine, and we can say /API/players to see our players data. So you can see it over here. So right now we need to actually host our client application, and if we visit here, if you visit /API/stream, we should be able to also see our stream route over here. So you can see the stream data over here, and any stream event we can be able to listen to it within this API route. So but we need to host the client application in order for it to be able to talk with our server application. So we need this URL actually to configure it on the client side. In order to do that, we need to actually come to our client application. Right now we're in client directory. So open the env.production and go ahead and specify, paste this URL, our remote server URL that is hosted on Google App Engine. So when we paste it over here, we want to end it with /API, just the way we have it over here in development. Alright, since we're done this, let's check our Google App Engine dashboard. So when we go back to our Google Engine app dashboard, we should be able to see this. So you can see our server is right now up. You can see the URL of our server over here. We can be able to click on it to open it in browser, and we can see the server is up running over here. We can visit /API/players to see our players data as well. We can click on this to see the players data, and we can also be able to monitor our resources over here. We can see how many versions we have actually deployed. So you can see our current version is up, and then the runtime is Node.js, the environment is flexible, and then you can see the service account and everything over here. So we can also set firewall rules. We can come to settings and also provide our custom domain names. We can disable the application from running after here in order not to consume resources. So if you have done this and you don't intend to use the app, you can go ahead and disable the application so that you don't get to pay Google free money. So since our app is up and running and we have started our client configuration, let's go ahead and then finish up the configuration. So under our client directory over here, we are specifying the URL for our remote server, which is the one from where we hosted our Google client and our Google server. That is our Node.js app on App Engine. So we specify the URL over here. This is the one we're using on our client application to talk to our remote server. So and we are going to go ahead and switch to a tab that has this client and git status. Check the status, and then everything is up to date. After we have done our configuration, let's go ahead and create a repo on GitHub. So come over here and click on this new repository, and we give it a name of SSE Spot Client. So and we want to make it private or public, whichever one. So let's go ahead and click. Then we copy this command over here. Let's copy the command and then open our terminal and navigate to the client directory. So and paste this. So remote origin already exists. Let's remove it. Git remote remove origin. So then let's paste the command again. So everything is all right now. So let's go ahead and push it to our git repo, git push origin main. So everything is pushed to our github. So let's go ahead and then check it out. So all the changes that we have committed, everything is pushed to our GitHub over here. So if we make any change, over here, we can still, if for instance we make any change in this component, we can still go ahead and then commit our changes and push to GitHub. So if it's to git status, we will see the changes. We can say let's stage it first, git add, then we will commit the changes. Then we can push to our our remote repo. Again, git push me. So our changes have been pushed yet again. So once our changes have been pushed, we can go ahead and log into our Vercel and host the application. So go to your Vercel account, depending on what you have set up your Vercel account, and click on add new. Go to projects over here and click on, it will show you all your lists. If you have connected your GitHub account, it will show you it will list all your projects under GitHub for you, so all your repo. So go ahead and click on import and leave everything as default and click on deploy. Let's wait for it to deploy our app to Vercel. Wow, so you can see our app is deployed over here, and then let's continue to click on continue to dashboard over here. So but then there are this app has generated some URLs for us. So if for instance we hover over this, we can see the generated domains. So if we click on this, we should be able to view our app. So this data is fetched from our Google API, but maybe when we click on this to vote, we will receive an error, of course error. If you inspect it in the browser, you should be able to see the error. So let's inspect in the browser, check our console log, and you should see cause error because we have not yet specified this domain on our server. So in order to do that, let's copy this domain over here and then go back to our VS Code over here, close this client directory. We have already hosted our client app and it's talking to our server, but we cannot make a post request to our server right now. So let's open the source directory on that server, source directory. Inside the source directory index.ts file, if you remember, we configured cause over here, but we only specify the local URL. So let's go ahead and specify our remote URL. So this should work. We are saying this, if a request is made from this URL, it should accept. And again, remember there are so many generated URL by Vercel over here. So this one too is okay, so you can see the URLs over here. If you click on this, we also open our application. So we want to go ahead and add this one too to our group of origins. So over here too, let's go ahead and add that one as well. And remaining on one domain, so there is another third domain again over here, this one as well. Can open our application. So we want to allow requests from all these generated domains by Vercel. So if maybe we are using our own custom domain that want to allow requests from that domain only, we can specify only the custom domain, but these domains we want to allow them. So after we have done all this, we still need to push our server again for everything to work perfectly. So open our terminal and navigate to the terminal for deploying our server to Google App Engine and go ahead and run the command npm run deploy. So and hit enter. So we say yes. Alright, so our changes have been pushed to our server again, and then we can go ahead and test our app and see. Well, if we come back to the browser over here, we should be able to test our app remotely right now. So if we click on vote, you should be able to communicate with our remote server. So we can vote any player and everything looks good. So let's continue voting and you can see. So let's go ahead and open this app in multiple browsers and see. Alright, so this is our live app. So you can see how it is hosted on Vercel and it's communicating to our live server hosted on Google Cloud App Engine. So, and if we go ahead and then vote this app over here, you should be able to see how it is reflecting in other browsers as well. So if over here too, if we go ahead and vote, it will reflect. If we vote for Cristiano Ronaldo, if over here too, we vote for Cristiano Ronaldo, and here too, if we vote for Cristiano Ronaldo, you can see the votes that are reflected in all the browser tabs. So we can go ahead and vote, and if Cristiano Ronaldo has more points than Neymar, it will switch the position of Neymar and Cristiano Ronaldo, and everything will be animated. So you can see how beautiful our application is looking. Everything is being streamed in real time. So if I open this application in my browser, and as users are voting in, as new votes are coming in, we can be streaming this in real time. So everything is happening in real time, and you can see the player that is currently voted. So this is looking so fantastic. So everything is working this real time, and I hope you have learned something new today. I hope with this knowledge you can go ahead and build your dream application or integrate a real-time streaming feature within your application. So go ahead, like, subscribe to my YouTube channel and turn on notification. My YouTube channel has more than 30,000 views on certain videos, 50,000 views. So please help me. My target is to get to 10,000 subscribers. Please help me get to 10,000 subscribers. Thank you, and may God bless you as you subscribe to my YouTube channel. See you in the next video. Bye.